Good afternoon. It's just a continuation. We're still doing Torah sheet form. So I'll start with the question 5. So I'll start with question 5. The question is saying, factorize this one. X to the power 3 minus 3x squared minus 4x plus 2. So factorizing that one, I think it is simple. We are going to use factorizing by grouping. So if we consider the first two factors, our GCF is x squared. So now you do that. X squared into x to the power 3 will remain with x. Minus x squared into 3x squared will remain with 3. What is common there? Our GCF there is negative 4. Negative 4 into that, you remain with x. So there it is supposed to be 12. This into that, you remain with 3. So now from there, it means we have something like this. X minus 3 and x squared minus 4. But this is not our final answer because there's something that we're supposed to do to the x squared minus 4. So now let's proceed. Moving x minus 3. So there we are going to apply different of two squares. So we say x plus 2 and again x minus 2. So now that's our final answer, factorizing. So that's our final answer. So now the same question is asking us to calculate the range of values of x. Calculating the range of values of x. So now let's do this. So now we want to calculate the range of values of x. Given this one, given x3 minus 3x squared greater 4x minus 12. So for you to calculate the range of values of x, what you're supposed to do is you're supposed to take this function the other side. So now taking that on the other side, it means we have something like this. X to the power 3 minus 3x squared. If this 4x crosses that, it will be negative 4x. If negative 12 crosses that, it will be positive 12. Then you say greater 0. Then from there you factorize. So we're going to factorize by grouping. So what is our GCF here? Our GCF is x squared. So now you do that. X squared into that, it's x. Minus x squared into 3x squared will remain with 3. What is our GCF there? It's negative 4. You do that, x minus what? Minus 3, you do that, then 0. So now from there, we have something like this. So even there, we're going to apply different of two squares. So x minus 3, then x plus 2, and x minus 2, you do that 0. So what is it that we want to find? we want to find the range of values of x. We want to find the range of values of x. So now let's do this. So we have x with x minus 3, x plus 2, and x minus 2. So finding the range of values of x, you draw a line like that one. You say infinity there, here negative infinity. Then from there, what is it that we have there? We have 3. So you do this, you say 3, 2, negative 2. So now you start now testing the values. So here if we pick 4, we substitute there. 4, we are having a positive. 4 there, we are having a positive. If we put 4 there, we're having a positive. Like we substitute 4 where there's x. So we're moving positive, positive, positive. So if you multiply the positives, there we're getting what? Positive. So we pick any value in between. So let's pick 2.5 here. We pick 2.5. So if I put 2.5 there, I substitute 2.5. We are having negative. I substitute 2.5 there, positive. I substitute 2.5 there, positive. So if I multiply negative times positive, it's negative. Times positive, it's negative. So let's pick. So if you test this one will be positive, the other one will be negative. So now what are the, we want to calculate the range of values of x. So the range of values of x here, it's negative 2, comma 2, because these are the one giving us what? Positives. So negative 2, comma that, union, then 3, comma infinity. So that's what you're supposed to do. So finding the ranges of values of what? The range of values of x. So I think we're done with the question 5. So this is what you're supposed to do. If you want to find the range of values of x, what you're supposed to do is to get the function from the other side to the other side. Then you say greater 0. From there you factorize the function. After factorizing the function, then you draw a line like this one. You say infinity, 3, 2, negative 2, then you start testing. So now after testing, the answers that you get, so that those are your what? The ranges of what? The range of values of x. So our final answer here is negative 2, comma 2, in brackets, union 3, comma negative infinity. So that's what you're supposed to do, and that's the question 5. So let's proceed. We proceed. Question 6. Question 6. So for question 6, we want to find the values of, or the value of p, the values of p and what? And q. Given this polynomial, px equal to px to the power 3 plus q x squared minus 3x plus 7. So we want to find the values of p and q given that polynomial. And we have factors. The factors that we have is x minus 1 and x plus 1. So we want to find the values of P and Q. So what is it that you're supposed to do? As in, for you to find the values of P and Q. Here you have to, let me do this. So we say solution for this one. So here you have to recall the factor theorem. So the factor theorem states, given a polynomial, so given a polynomial px and a number, or let me just do this, a number a. So if x minus a is a factor of p of x, which is the polynomial, then f of a is equal to 0. So that's the concept we're going to use, the factor theorem. So given a polynomial px and a number a, if x minus a is a factor of that polynomial, then f of a is equal to 0. So now let's solve. So we have two factors here. The first one is x minus 1. The second one is x plus 2 or x plus 1. So we have two factors, x minus 1 and x plus 1. So first, let's find the equation for x minus 1, the first factor. So you say factor number 1. So we have x minus 1. So if you do this, you say, so meaning x is equal to 1. So what are we having? We are having p of 1 equal to p multiplied by 1 to the power 3 plus q multiplied by 1 to the power 2 minus 3 multiplied by 1 plus 7. So that's what we're having if we substitute 1 there. So now let's proceed. So there we get in p, 1 squared is 1, multiplied by q we get in q, so getting negative 3 plus 7. So now, so we have p plus q. So if you add those two, we're getting what? So if we add those two, we're getting plus what? We're getting 4. But following the theorem is saying f of a must be equal to what? To 0. So now you equate this function to 0. So equating that one to 0, it means we're moving something like this. P plus q plus 4 equal to 0. Then you say p plus q equal to, the 4 is crossing the equal sign. Since it is positive here, then the other side it will be negative. So with negative 4. So you indicate to say equation 1. So this equation is for the first factor. So now let's solve another equation for the second factor. Let's solve another equation for the second factor. So our second factor factor 2 is x plus 1. So if you do that, so our x, it means, is negative 1. So we are solving p of negative 1. So if we substitute, we are having something like this. P multiplied by negative 1 to the power 3 plus q multiplied by negative 1 to the power 2 minus 3 multiplied by negative 1 plus 7. So there we go. It's negative p. We're getting negative p. Then there plus q plus 3 plus 7. So that's what we're getting. So let's proceed. Let's proceed. Negative p plus q. So if you add the two, we're getting 10. So now, following the concept, the same concept, we say p of a should be equal to 0 if that one is a factor. So now from there, we are having our second equation is, we say negative p plus q plus 10, we equate this one to 0. So we're moving negative p plus q equal to negative 10. So that's our second equation. So you even indicate to say EQ2. So that's our EQ2. Let's proceed. We have two equations, equation 1 and equation 2, with two unknown quantities, which is P and Q. What is our aim? Our aim, we want to find the values of what? Of P and Q. So how are we going to do that? We have two equations. So we're going to do that simultaneously, since we have this equation and that equation. So we're going to solve for P and Q simultaneously. So now let's do that. Let's do that. So our first equation is P plus Q equal to negative 4. Our second equation is negative P plus Q equal to negative 10. So we're solving it simultaneously. I can say 1, 1. If I multiply this by that, I'm getting P plus this by that, Q equal to negative 4. Again, I multiply this by that, I'm getting negative P plus this by that, Q equal to this by that, negative 10. Let's proceed. We want to find the values of P and Q. So we are there now. You add. So adding now, if I add these two, it's 0. I add these two, we're getting 2Q equal to, if I add negative 4, negative 10, I'm getting negative 14. Then from there I say over 2, cancelled, cancelled, Q is equal to 2 into negative 14 is negative 7. So meaning our value of Q is negative 7. We are not done. We still also want to know the value of Q, the value of P, since the value of Q is negative 7. So what are we going to do? So Q equal to negative 7. So you can pick any function you feel like. So if you want, you can go for the first function. If you want, you can go for the second function. Pick the one you feel is the easiest to you. So now let's do this. Let's pick function number 1. So we say P plus Q equal to negative 4. So what is our Q? Our Q is negative 7. So now we say P plus, you substitute now. Where there is Q, you put negative 7. You say negative 7 equal to negative 4. So now from there you say P, positive times negative, it's negative. So you say minus 7 equal to negative 4. So P equal to, so this negative 7 can cross the equal sign. So once it crosses the equal sign, the sign changes from it being negative to it being positive. So you say negative 4 plus what? 7. What is now the value of P? What is now the value of P? If you add the two, the value of P is 3. So that's the value of P. That's what you're supposed to do. That's what you're supposed to do. So let's continue. So that's question 6. It means we've solved for Q and P. If I think it is clear, let's proceed. Question 7. Question 7. We have this polynomial P of x equal to 2x to the power 3 minus x squared plus ax plus b. So now what is the question saying? The question is saying if this polynomial is divided by x minus 2, the remainder that we are having is what? Is 14. So if this polynomial is divided by that, we are having that remainder, 14. And again, if the same polynomial is divided by yes, we are having 14. So now let's divide this one. So now let's divide this one. So if this polynomial is divided by that, we are having the remainder 14. So still we're going to use the same method that we've used. We're from just using. So now let's do this. Factor 1. The factor 1 we have is x minus 2. X minus 2. That's our factor 1. X minus 2. Okay. So now let's do this before we proceed. Let's do this. So if this polynomial is divided by that, we are having that remainder. And again, we have another factor. So if this polynomial, the same polynomial is divided by, again, what is that? So if it is divided by x plus 3, we are having negative 8, 6 as our remainder. So now the question is, calculate, find the value of A and what? And B. So now finding the values of A and B is simple. What is it that we're supposed to do? What is it that we're supposed to do? So we have two factors. So factor 1, we have x minus 2. So now let's use the same method, and we say it is giving us a remainder 14 if divided by that. So now we're going to say P of 2 is equal to, then you substitute. You say 2 multiplied by 2 to the power 3 minus 2 to the power 2 plus A multiplied by 2 plus B. So now from there, Let's continue. That's 2. So this to the power that is 8. 8 multiply, okay, let me just do this. We say 8, that's 4, plus, we say 2a plus b. Then from there we are getting 16 there. We say minus 4 plus 2a plus b. So if you add, you say 16 minus 4 is 12. So we have 12 plus 2a plus b. So now the question is saying, after dividing by this one, the remainder is 14. So now you equate this function to what? To 14. So equating that one to 14, we're having something like this. So we're having something like 12, or let me just say 2a plus b plus 12 equal to 14. So now from there we have 2a plus b equal to 14. So if this 12 crosses the equal sign, minus 12. So 2a plus b equal to 14 minus 12 is 2. So that's our first equation. That's our first equation. So now you even indicate to say 2a plus b equal to 2. Equation number 1. So let's solve the second factor. So our second factor is x plus 2, x plus 3. So factor 2. So we have x plus 3. So this one divided by that, they are saying it is giving us a remainder of negative 86. So now let's solve that one. We solve the equation. So p of the 8 will be negative 3. If you say x plus 3 equal to 0, meaning your value of x is negative 3. So p of negative 3 equal to 2 multiplied by open brackets, negative 3 to the power 3, minus negative 3 to the power 2, plus a multiplied by negative 3 plus b. So that's what we're getting. So now from there, if we multiply there, here we're getting negative 54 plus or minus, what is it we're getting there? We're getting 9. Then we say minus 3a plus b. That's what we're getting. So now from there, if you add these, you're getting negative 63. Negative 63 minus 3a plus b. So now let's proceed. The question is saying, after dividing this one by that, we are having a remainder of negative 86. So now let's proceed. The question, you equate this one to negative what? To negative 16 or negative 86. So now let's do this. So we have let's equate this function to a negative 86. We are having negative 63 minus 3a plus b equal to negative 86. Negative 63 there is constant, so it can cross the equal side, it can go the other side. So you have negative 3a plus b equal to negative 86 plus what? 63. Because there it is negative, so it has crossed the equal side there, the sign has changed from it being negative to it being positive. So from there now, we're having negative 3a plus b equal to, so if you subtract here, you're getting negative 41. So you even indicate to say equation 2. So now our aim is to find the values of what? A and B. Since we have now two equations, this is our first equation and our second equation is that one. So we are going to solve for A and B simultaneously. So now let's proceed. Let's solve for A and B simultaneously. Our first equation here is 2A plus B equal to 2. Our second equation is what? Our second equation is negative 3A plus B equal to negative 41. So now let's do this. Solving this one simultaneously, I can say 1, negative 1. So that if I multiply this one by 2A, I'm getting 2A. 1 by B is B. 1 by 2 is 2. So now let's continue. If I multiply this negative 1 by 3A, I'm getting positive 3A. And again, if I multiply this negative 1 by B, I'm getting minus B. If I multiply this by that, I'm getting positive 41. Then from there, we add now, because 0 is there. So now, what is 2A plus 3A? We are getting 5A if you add 2A and 3A. Positive B plus negative B, the answer is 0. So you do that. You do that. So the answer is that. So now from there, let's see. So with negative 3 plus B, negative 3A plus B. So this one is supposed to be equal to, let me say, this one is supposed to be equal to negative 23. Yes, negative 23, if you do the calculations. So now from there, we are having 23 here. So now if you add the 2, If you add the 2 even there, yeah, it is supposed to be 23. It is supposed to be 23. So if you add the 2, you say 2 plus 23 is 25. So we are having 5A equal to 25. So now let's solve for A now. You say over 5, even there over 5. So you cancel. Our A is, so 5 into 25, the answer is 5. So the value of A here is what? Is 5. So now we continue, because we've just found the value of A. We also want to know the value of what? B. So knowing the value of B, what is it that you're supposed to do? So for you to know the value of B, what you're supposed to do here is to get any function. If you want, you can get this one. If you want, you can get the down function. So now let's do this. Let's pick the one on top. So we say 2A plus B equal to 2. So what is A? A is 5. Meaning where there is A, you put 5. You substitute 5 there. So you say 2 multiplied by what? A is 5. You say 5 plus B equal to 2. So now from there, what is it that you're supposed to do? 2 multiplied by 5, you're getting 10. Plus B equal to 2. So there we go. We want to know the value of B. So now you say B equal to, this 10 can go the other side because it's constant here. So now you say 2, since it is positive, if it crosses the equal sign there, it will be negative. So you say 10. So B is equal to, what is 2 minus 10? 2 minus 10 is negative 8. So that's the value of B. So this is what you're supposed to do, as in for you to find the values of B and A. Just follow the procedure nicely. I think that's what you're supposed to do. Let's proceed. So here we are saying 2A plus B equal to 2. What is A? A is 5. Then you substitute. Where there is A, you put 5. Then plus B equal to 2. If you multiply the 2, you're getting 10. Then plus B equal to 2. So from there now, you make now B the subject of the formula. So making B the subject of the formula, so you say B equal to 2. Since 10 is positive this side, if it crosses the equal sign there, it will be negative. So now you're having something like B equal to 2 minus 10. Then from there, B equal to, if you do the subtraction, you're getting negative 8. So that's your value of B. So now let's proceed. Let's proceed. Question 8. Let's do question 8. What is the question saying? The question is saying, given this polynomial, Px equal to 2x to the power 3 plus ax squared minus 6x plus 1. So if this polynomial is divided by this x plus 2, is twice the remainder obtained when the same polynomial is divided by x minus 1. So what is the meaning of that? So before you even do the final answer, what you're supposed to do here is to find the equations first. You have two factors. So it means you're going to have two equations. The equation for this one and the equation for x minus 1. So now let's begin with the equation, let's begin with the x plus 2. So let's find the equation for x plus 2. So the equation for x plus 2, or the function for x plus 2, we say factor 1, we have x plus 2. So if you equate this one to 0, it means you have x equal to negative 2. So what are we solving? We are solving P of negative 2. That's what we're solving. So P of negative 2, it means you're having something like this. 2 multiplied by negative 2, you say to the power 3, plus a multiplied by negative 2 to the power 2. Then from there you say minus 6 multiplied by negative 2 plus 1. That's what you're supposed to do. So now from there, let's continue. What is it that you're getting if you say negative 2 to the power 3? It's 8. So negative 8. So negative 8 multiplied by 2, you're getting negative 16 here. Plus, so if you say negative 2 squared, that's 4. You say 4a. Minus, so negative times negative, it's positive here. So you say plus 12 plus 1. So if you do the additions, it means you're having something like this. 4a plus 12 plus 1 minus 16. So it means you 4a minus 3. So your first equation here is 4a minus 3. That's your first equation. So now let's do this. So here we're saying 4a minus 3 is our first equation. So you say equation 1. EQ1. So that's your first equation. So now let's solve equation 2. using the second factor, because we have two factors here, x plus 2 and x minus 1. The one we've solved here is for x plus 2. Now we want to know the equation for x minus 1. So now let's solve for that. So x plus 2, as usual, you say negative 2, equal to that, you multiply, you add, and you get that. So now let's find the equation or the function for the second factor. What is our second factor? Our second factor here is x minus 1. So you say x minus 1. So if you equate this x minus 1 to 0, it means you're moving x equal to 1. So we're solving now for p of 1. So p of 1, meaning where there's x, the one you're seeing here, it has replaced what? It has just replaced x. So where there's x in that equation, you substitute what? 1. So now you say 2 multiplied by 1 to the power 3 plus a multiplied by 1 to the power 2 minus 6 multiplied by 1 plus 1. So that's what you're supposed to do. So now let's proceed. What is 1 to the power 3? We know it's 1. So the same 1 multiplied by 2, we're getting 2. Plus, what is 1 to the power 2? It's 1 still. The same 1 multiplied by a, we're getting a. So now you say plus a. What is 1 by negative 6? It's negative 6. Plus 1. So now let's collect the like terms. We put things in order. So with a plus 2 minus 6 plus 1. Or let me just do this. We say plus 2 plus 1 minus 6. So what is it that we're getting? So we're getting a minus 3. That's what we're getting. So that's your equation 2. So you even say EQ2. So now, since we have two equations, equation 1 and equation 2, it's now easy for us to solve for A. So how are we going to solve for A? The question is saying what? The question is saying, if divided by this one, the answer is twice divided by that one. So what is the meaning of that statement? So the statement means this. So don't forget, we have two equations. Our first equation is 4a minus 3. Our second equation is a minus 3, or minus 3, yes. So now, the statement is saying that divided by that is twice. So now you say 4a, because that's our first equation, equal to, so twice this one. So you say 2a minus what? 3. That's the meaning of that. So we are saying 4a minus 3 is equal to twice a minus 3. We can now solve for a. So now let's proceed. We have 4a minus 3 equal to, let's multiply now. 2 by a is 2a. 2 by negative 3 is negative 6. So now since we have that, we can now collect the like terms. So collecting the like terms, it means now this 3 is going the other side. This one is going the other side. So now collecting the like terms, we have something like this. 4a, when this 2a crosses the equal sign, since there it is positive, it means it is supposed to be negative this side. So now from there you say minus 2a equal to, then negative 6 remains the way it is, negative 6. What happens to this negative 3? This negative 3 is close to the equal sign. So now the sign changes from it being negative to it being positive. So we're moving something like positive 3 there. Let's proceed. What is 4a minus 2a? We're getting 2a. If we divide, we're getting 2a, or we subtract, we're getting 2a. Equal to, what is negative 6 plus 3? Negative 6 plus 3, we're getting negative 3. What is our aim? Our aim is to solve for a. So meaning we're going to divide both sides by negative by 2 so that to make a the subject of the formula. So dividing both sides by 2, we're getting something like this. Over 2, we say over 2, even they are over 2. So 2 into 2, that's 1, you cancel. So you say a is equal to negative 3 over 2. So that's our final answer. Negative 3 over 2. So what is just important here is to understand the statement. After you understanding the statement, I think if you just understand the statement, then it becomes easy now for you to solve for a or for any letter asked. So like in this case we have a. So meaning the value of a, the final answer of a is negative 3 over 2. So that's what we're supposed to do. So this is question 8, tutorial sheet 4. The one for polynomials. Don't forget, we're solving polynomials today. Okay, let's proceed. Let's proceed. Question 9. Let's do question 9. So we're changing the question there. We are now doing question 9. What is the question saying? The question is saying the polynomial, this polynomial px equal to 3x cubed plus 2x squared minus px plus q is divisible by x minus 1. So here, the question it is changed. So here they've just said it is divisible by x minus 1. So just know that your remainder is what? Your remainder is 0. So it is just divisible by this minus giving us the remainder. So if the remainder is not given, just know that the remainder somewhere there is 0. So now from there, let's proceed. The same question is saying it gives the remainder 10. The same polynomial gives the remainder 10 if divided by x plus 1. It gives the remainder 10 if divided by x plus 1. So what is the question saying? Find the values of p and q. Find the values of p and q. Find the values of p and q. So for you to find the values of p and q, we're supposed to solve. We're supposed to solve for x minus 1 and again solving for x plus 2. Because of x plus 1, because we have two factors here. We have x minus 1 as our first factor and x plus 1 as our second factor. So now let's begin with this one. The one they are saying the remainder is 0. So now we begin with that one. So let's find the equation for x minus 1. So you say factor factor number 1 with x minus 1. So if you equate this one, x minus 1 to 0, you're getting x equal to 1. So it means we're solving for p of 1. So now let's substitute. 3 multiplied by 1 to the power 3 plus 2 multiplied by 1 to the power 2 minus p multiplied by 1 to the power, no power there, so plus q. Plus q. So now let's do this. What is 1 to the power 3? It's 1. 1 multiplied by 3, it's 3. Plus, that to the power 2, it's 1. Multiplied by 2, it's 2. So minus p plus q equal to that. So let's proceed. So if you add the 2, you're getting 5 here. You say 5 minus q plus, not minus q, but p, yes. Minus p plus q. So for this one, we're going to apply the factor theorem because the remainder is not given. So we are going to equate this one to 0. So equating this one to 0, what is that we're getting? So you say 5 minus p plus q equal to what? 0. Because the remainder for this one is not given. So what is that we're supposed to do? To apply the factor theorem, where we say if x minus a is a factor of this polynomial, then f of a should be equal to 0. So that's the theorem we're going to apply this here. So now let's proceed. So we have negative p plus q equal to, this 5 is constant, so it can cross the equal sign. So we are having negative 5. So that's our equation 1. So don't forget to indicate your equation 1. Don't forget to indicate. So let's proceed. I think it's easy, you know what we've done here. By that, you do that, you get that. So meaning our first equation here is negative p plus q equal to negative 5. That's our first equation, equal to negative 5. So we want to find our second equation. The equation is saying, if divided, this same polynomial divided by x plus 1, if this same polynomial is divided by x plus 1, it is giving us a remainder of what? 10. The one from solving, the remainder was not given. Now the second one, this factor, the second factor, the remainder is given. If this one divided by that, we're getting, our remainder is 10. So now let's solve for this one now. So if you equate this equation to 0, you say x minus plus 1 equal to 0, meaning your x is equal to what? 1. Then from there now you say, it means, no, not 1, negative 1. Yes. Yes, it is supposed to be negative 1. So it means we're solving for p of negative 1. That's what we're solving for, p of negative 1. So now let's do this. 3 multiplied by negative 1 to the power 3, plus we're using the same polynomial. Don't forget that, we're using the same polynomial. So 2 multiplied by negative 1 squared minus p multiplied by negative 1 plus q. What is negative 1 cubed? Negative 1 cubed is negative 1. So negative 1 multiplied by by 3, we're getting negative 3. So there you say negative 3 plus. What is negative 1 squared? Is positive 1. So positive 1 by 2, you're getting 2. Negative times negative there is positive. So what is that we're getting there? We're getting positive P. Then you say plus Q. So we proceed. If you do the addition here, you're getting negative 1. Then plus, so you're getting negative 1 plus P plus what? Q. But what is the question saying? The question is saying, if this polynomial divided by that, we're moving the remainder that. So now you equate this equation to what? To 10. So now equating that one to 10, so we're getting something like this. We're getting negative 1 plus P plus Q equal to 10. So that's what you're getting if you equate this one to 10. 1 is constant here, negative 1 is constant here. So what is that we're supposed to do? This negative 1 is going to the other side because it's constant there. So we have now P plus Q equal to 10. So if this negative 1 crosses the equal sign, it means the sign changes now from negative to positive because it has crossed that. So now plus 1. That's what we're having. Let's proceed. So it means we're moving something like, let me do this. Change my marker. So it means we are having P plus Q equal to what? What is 10 plus 1? You know the answer is 11. So we're using 11 there. And you indicate to say that's your equation 2. What is the question saying? We want to calculate the values of P and Q. Now since we have two equations, our first equation is what? Our first equation is negative P plus Q minus 5. That's our first equation. So AQ1. So our first equation is negative P plus Q equal to negative 5. Our second equation is P plus Q equal to 11. So for us to find the values of P and Q, it means we're going to do that simultaneously because we have two equations with unknown values. What are these unknown values we're talking about? We're talking about P and Q. We don't know the value of P and we don't know the value of Q. So that's the reason why I say we are going to solve for the unknown values using simultaneous equation. So now let's do this. So solving this question simultaneously, let's do this. Our first equation is negative P plus Q equal to negative 5. So that's our first equation. Our second equation is P plus Q equal to 11. No, not in negative 11, but 11. Yes, not negative 11. So now from there, let's solve for P and Q simultaneously. You say 1, 1. I think you know the method I'm using here. So now you start multiplying. 1 by negative P, you're getting negative P. 1 by Q, you're getting positive Q. Equal to 1 by negative 5, you're getting negative 5. We proceed. 1 by Q, by P, you're getting P. 1 by Q, you're getting Q. 1 by 11, you're getting 11. So what is our next step? Our next step is to add now. You do that. So you say plus. So if you add negative p and p, that's 0. If you add negative p and p, you're getting 0. If you add q and q, you're getting 2q. So since here it's 0, so we'll indicate nothing here. So we'll just consider the QQ. That's what we'll consider, because if you add negative PP, we're getting 0. So we'll just consider the QQ. So now you say Q plus Q, it's 2Q equal to. From there now we say negative 5 plus 11. What is the answer? If you do that, we're getting that's 6. But we want to solve for Q. How are we going to do that? We're going to divide both sides by 2, because we want to make Q the subject to the formula. So now you say over 2 here, even there over 2. Then after that, you say 2 into 2, that's 1. So meaning here, this side you remain with Q. So you say Q is equal to, I think 2 can go into 6. How many times? 3. So the value of Q is 3. So Q is equal to 3. Let's proceed. So we've just solved for Q, but we also want to know the value of P. How are we going to do that? You get any function or any equation if you like. So if you want, you can get this one, or if you want, you can get the first one. So let me get the second one. So the second one, we have P plus Q equal to 11. And we know that Q is equal to 3. So what are you going to do? You're going to substitute there now. Where there is Q, you put 3 for you to solve for P. So now let's do that. So it means we have P equal to 11. Oh, let's do this. P plus Q is what? Q is 3 equal to 11. Yes. So that's what you're supposed to do. So now from there, you say P is equal to 11. So now the positive 3 is crossing the equal sign. So since it is positive, that's this side, the other side it will be negative. Yeah. Minus 3. So there we go. What is the value of P now? If you subtract, P is equal to what? P is equal to 8. Is it 8 or 7? I think it's 8. Yes. So that's what you're supposed to do. Yes, so we've solved for P and Q simultaneously because we had 2 equations with unknown quantities, 2 unknown quantities. So we had P, Q, P, Q. And you can't solve for P and Q if you decide not to use simultaneous equation. So I think there are other ways that you can use, but the easiest is by using the simultaneous, as in by using the method I've used here. I don't know. So you guys, if you have any method, you can use it for as long as it is giving you Q equal to 3 and P equal to 8, then there's no problem. Let's proceed. Okay, so now this marks the end of our tutorial today. I think we'll continue on Friday. Thank you very much, you guys. Thank you. See you next week.